but at the same time the temperature is increasing. So when the temperature increases, the other elements, there isn't anything to do except to fuse into other elements. So when it starts fusing, it starts building up itself, because helium is building other heavier elements, as we can see. That's why it's becoming bigger in size. And when that happens, it starts now into, for example, old age or death. So there is 3 fates a star can take. It can actually be either a white dwarf, a neutron star, or a black hole. But how do we know which stage a sun is going to take, depending on what factor? What do you think? It's mass, yeah. So depending on the mass of the star, when it was born, we would know what's the end of that star. So let me give you an example. Okay, I gave this question. So far, we were talking about sun-like stars. And we talked about how it's going to be formed and how it changes to a red giant, for example. When we say red giant, there is no hydrogen, so it changes helium into heavier elements. And then what happens is we're going to the planetary nebula. And what does that mean? So we talked about changing helium into other elements, right? But then it doesn't, it starts, keep processing, but there isn't other elements it can fuse into. So slowly, the other element starts to disperse, and we call it planetary nebula. And what stays behind is actually a white dwarf. The white dwarf is actually the core of the sun, the star, sorry. And with time, because there is no energy, it starts becoming a black dwarf. It dies, basically. Yes, it's just a black dwarf in space. It's like a debris. حين مثل ما قلنا الشيء المهم أو العامل المهم اللي يغير النجمة أو نعرف كيف النجمة بتنتهي آخر شيء اللي هو الماس أو وزن النجمة. فنحن حين من أول ما بدينا ياسين نرمس عن النجوم اللي شبيهة للشمس، زين؟ فقلنا إن حين تغير استوى مثلا ريد جاينت اللي هو فيز، قلنا يوم يخلص الهيدروجين يستخدم الهيليوم يسوي شيء ثاني. عقب عندنا البلانيتري نابولا اللي هو يوم خلاص ما في شيء، ما في اندماج ثاني، فشو يبتدي خلاص الاشياء الثانيه لان there is no process so the gravity wins the other things just الاشياء الثانيه خلاص يعني تبتعد من النجمه. وبهالطريقه شو يتم عندنا الوايت دوارف اللي هو الجزء الاساسي من النجمه اللي هو يطلع الفيوجن مثل كور يعني. ويا الوقت هذا بيخوز الانرجي ما بيكون موجود، بتختفي يعني النجم، بتكون كأنه شيء عادي في السماء. And then we talk about huge stars and giant stars. It's different, a little bit different from the sun-like stars because it starts as, it has a very high temperature. Okay, it starts with higher mass, around 1.5 to 3 times the mass of the sun. And we're talking about giant stars over 3 times the mass of the sun. So it's huge stars. It changes into red supergiants. And what's the difference between red supergiant and the red giant is that when the helium ends and then changes to other elements, the other elements also starts to fuse into other elements and so on until all the elements end. But what happens is that because it keeps processing, it keeps fusing into other elements, the gravity can't hold it anymore. So what happens is a supernova, a huge explosion. This explosion, it's very huge, basically. And then when we talk about huge stars, it ends into neutron star, and neutron star basically is the core of the sun or the star, and it keeps spinning because of the explosion. Just keeps spinning. And when we talk about supernova, when it's related to giant stars, it becomes a black hole because gravity is so huge. It just takes all the light around it and everything around it. So that's how we know each phases of the stars. حين يوم نرمس عن النجوم الكبيرة شو يصير؟ حين رمسنا عن الريد جاينت هني، فالسوبر ريد جاينت اللي هو لأن نحن ياسين نقول الاندماج مال الهيليوم إلى elements ثانيات، فشو يصير؟ يندمج أشياء ثانية تندمج إلى أشياء ثانية. فشو يصير؟ حين الجرافيتي الجاذبية تكون يعني ما تقدر تيود هالشيء خلاص، فتنفجر النجمة. هاي يسمونه السوبر نوفا فيز. عقب على حسب وزن النجمة يا تكون نيوترون ستار اللي هو النجم اللي تجلس يعني it spins around itself. عقب عندنا البلاك هول اللي هو لأن الجاذبية وايد كبيرة فتاخذ كل شيء حواليها. ف this is how we know the stages of a star. But if I'm talking about our sun, what do you think is the fate of our sun? Black dwarf, صح. So الشمس مالتنا آخر شيء يوم بتنتهي بتكون black dwarf. So one point is going to be white dwarf and then black dwarf. And then we have one more exercise to classify the stars. So I think you all worked on activity 2. We have activity 3. There is a couple of stars that we've chosen, I think 3 stars. Let me show one of the papers. Okay, everyone has activity 3, right? Okay, so activity 3, we have 3 stars. We have star A, C, and B. You've already calculated the temperature for them, for the previous exercise. And I want you to find the color of the star. To find the color, you can refer to this graph over here. So basically from the temperature, you would know the color of the star. And then we have the spectral class. The spectral class, we have another table which talks about the temperature. You'll find the information there. And then the star type, from this graph over here, you would know what star type. Is it a red giant? Is it in the main sequence? And then I want you to rank it from the biggest star to the smallest. So I'll give you 10 minutes to work, less than 10 minutes to work on this exercise. If you have any questions, we're around. So you already calculated the temperature from the previous equation. Yeah. Yes, these are the ranges. So so you already calculate the temperature, right, from the previous exercise? Okay, so the second column is to find the color. So basically from this graph over here, and from the temperature, you would know the color of the star. Yeah? So just to make it easier for you, just write the temperature in the table that you have for exercise 3. This one, yeah. Yes. The equation, you already calculated it. If you didn't, you calculate it now. Okay, for those who didn't find the temperature earlier, let me tell you the temperature. So for star number A, it's 7,624. For star number C, 3,533. And for star number D, 7,243. Okay? Yeah? Okay, great. Perfect. Hey. So for star number A, it's 7,624. For C, 3, 5, 3, 3. 3, 3. And then D, 7, 2, 4, 3. Okay. Eight, 7, 6, 5, 4, 3, 2, 1. Time's up. Okay. Who finished from the team? You finished, you finished, you finished. Okay, let's go through it together. We have 3 stars. We have A, C, and D. Let's talk about the temperature for each one. I already gave you the answer, so let's go for the color. The color for star A is white. Okay. Spectral class is A. Star type is giant. We'll talk about the ranking at the end. For star C, the color is red. The spectral class is K. Star type is subgiant. For D, the color is yellow. Spectral class is F. Star type is in the main sequence. And when we talk about the ranking, who can tell me the ranking of the stars? Yes? C, A, and B? So which is the biggest? Which is the biggest? Is it the giant, subgiant, or main sequence? Hey, subgiant is biggest? Subgiant. Yes, so the biggest is the giant. And then comes the subgiant from its name, subgiant. And then the main sequence. So just going back to our talk, which one? Which one is our star? Where does it lie? Main sequence, that's right. Okay, so now that we know, you're all basically scientists. You know how to classify